Alright, so we're going to evaluate f at 0, so let's write it down. Everywhere we have x, we're going to put a 0, and then we'll solve this to find our y-intercept. We'll work inside the parentheses first, and this is -3 squared, which is going to give us +9, which is -18 plus 8, so we get the y-intercept, where it crosses the y-axis, is going to be -10. F asks us to find the axis of symmetry. The axis of symmetry, a lot of times I'll just abbreviate it in that way, is always, always, always an equation, and it's x equals whatever the x value of the vertex is. So what is our x value of the vertex? 3. So in this equation, our axis of symmetry is the equation x equals 3. And I don't have part G on here, which is off of your page, but it asks for the domain and it asks for the range of the problem. But we're going to graph it because it's easier to tell domain and range once you graph it. So we're going to use this information. Let's start with our vertex and try to approximate 3, 8. Roughly 3, 8. We say it opens down. Okay. Where does it cross the x-axis? At 5 and 1. So it's going to cross here and here. So that's enough to open down and cross those. Also, where does it cross the y-axis? -10, right? Here's our y-axis. This is the y-intercept. This is where it crosses the y-axis. So I can put that on there as well. So extend my graph. Their axis of symmetry will be a dashed vertical line through x equals 3. That's your axis of symmetry. Okay, so we have a rough sketch of this graph now. The domain is the x values, the leftmost to the rightmost, so our domain is going to be from -infinity to +infinity. The range is the bottommost. Well, the bottommost are arrows that are pointing down, so it's -infinity to the topmost y value point, which is what? 8. So by looking at the standard form, we can calculate all these different characteristics to be able to sketch a pretty accurate graph of our quadratic equation. Okay, so use the vertex and intercepts to sketch the graph. So first of all, this is y minus 1 is equal to x minus 3 squared, which this is not in our standard form. I'm going to flip back to the last page. Ax squared plus k, the y equals is by itself. Is our y equals by itself? No, so we want to add 1 to both sides basically. So the function we're going to be working with is actually x minus 3 squared plus 1, because when you move then add 1 to both sides, and this is what we're working with. From here we can name the vertex. What is our vertex going to be? Good, 3, 1. Okay, and it says use the vertex and the intercepts. Alright, let's try the x-intercept first. To find the x-intercept, what do? Let y equal 0. Okay, so that means I just have, if this becomes 0, I have this is equal to 0. So I like to put it on the left. So 3 x minus 3, squared plus 1 is equal to 0. And we're solving this for x. So how do we undo a square? Take the square root of both sides. So then just gives us x minus 3 is equal to plus or minus. Don't forget that. Now what is the square root of -1? We just learned that. Good. It's really I. if I bring that up here, so I can continue on, so I have x minus 3 is equal to plus or minus I, and I solve for x, so I add 3 to both sides. I just get x is equal to 3 plus or minus I. Now, if I needed to write those out, I would say 3 plus I and 3 minus I. Okay, these are my x-intercepts. Let's determine our y-intercept. So to find the y-intercept, what do? Let x equal 0 and solve. So I have y is equal to 0 minus 3 squared plus 1, and I'm plugging this into the original function. Negative 3 squared is a positive 9. 9 plus 1 is just 10. Now, as an ordered pair, a y-intercept is the ordered pair like this. So this is where it crosses the y-axis. So let's go do a sketch. Y equals 10, so it's positive 10. What about, will our parabola open up or down? What's this known number out front? It's a known 1, but it's positive. All we care about the sign. So we know this thing opens up. How am I supposed to know where it crosses this x-axis? What's that mean? That means there's no real roots. There's no x-intercepts. Okay, so there's no x-intercept. So basically we go to our vertex. 1, 2, 3, 1. Here's our vertex. And we're just going to sketch a graph. Now, we're just doing a sketch right now. I could use a value of x and substitute for y to pick a point over there to be precise if I needed to. But in my math lab, you need 2 points. You need a vertex and one other point, which we used our y-intercept. We used this vertex and this point. So in math lab, you only need, in my math lab, you only need the vertex first and then give them this point and it'll graph your parabola for you. Okay, good. Next, the vertex of a parabola in the form. So now we have our standard format. F of x equals ax squared plus bx plus c. And I ask you right now, right off the front, if I give you one, can you tell me what the vertex is? And it's not in that same format. So we need a formula. When our vertex, when our quadratic is given in this form, we need a formula to find vertex. And that formula is going to be negative b over 2a is the x value. Whatever you get for this x value, you plug it back into the function and evaluate, and that will be your y value. That gives you your ordered pair vertex. This will give you your x value. Whatever your answer you get for this, if you plug it back into the given equation, that's going to be your y value. That's what this means. Okay. Alright, so now we actually have one that we're going to work with. It's hard to see, so our function, the given function is negative x squared minus 6x minus 5. We want to know a few things. We want to know our vertex, our x-intercept, and our y-intercept. Okay, in this one, what is A equal to? Negative 1. What is B equal to? Negative 6. And what is C equal to? Negative 5. Okay, I can't look at that. It's not in standard form and spit out my vertex. So what I need to do is use my formula, and I'm going to use negative B. My x value is negative B over 2a. Opposite, and in this case, B is negative 6. 2 times a is negative 1, so we get 6 over negative 2, which is negative 3. So my vertex, the x value is negative 3. Okay. To get the y value, I plug it back into the original function. So The original function evaluated at my x value is going to be negative everywhere there's an x, put a parenthesis, and I'm pulling this from this original function. Everywhere there's an x, put a parenthesis, and now we're going to evaluate this at negative 3. Negative 3 squared is 9. The negative sign just drops down out front. Plus 18 minus 5. This simplifies to 4. And now we have our vertex. Axis of symmetry, just for extra practice, axis of symmetry is going to be the equation x equals what? The x value of your vertex, negative 3. Whatever your x value of your vertex is, the axis of symmetry is that equation. Now they ask us to find the x-intercept and the y-intercepts.